Hello, welcome to this week 4 video for Computer Science 201. Today we're going to be talking about conditional repetition, so specifically for loops, while loops, that kind of thing. And I'm just going to show a few slides and show a few examples. So this is chapter 13. Conditional repetition is another way of thinking of it is as a control statement. It's used to control the flow of execution for JavaScript. So like basically when something happens and how often something happens. It's also conditional execution, meaning that it only executes while something is true. So basically it'll either do the thing or not do it based on various conditions. Many problems involve repeating a task over and over until a specific condition is met. For example, rolling a dice until 7 is obtained. That's something that means we have to roll each time, and if 7 is not obtained, then we have to roll again. While loops are what provides this type of conditional repetition. So a while loop basically says while some test is true, then do some statements. So the while Boolean test means while Boolean test is true, then do these statements. So it's going to be repeated until this is false, at which time this is false, it skips this and goes on to the rest of the statements. So when the browser first encounters this while loop, it evaluates the Boolean test. If that succeeds, these statements are executed. If it does not succeed, it skips those statements and goes on and does the rest. It's going to keep looping and doing this as long as the Boolean statement is true. So for example, here we see rolling some dice, and I'm going to show this example in a little bit on a browser. We roll 1, then we roll 2. We say what the roll is. If the rolls are not equal to each other, we keep rolling. So we say roll 1 equals random int 1 6, roll 2 equals random int 1 6, and we display those results again. So the way that looks is as follows. I'm going to click roll until doubles. Notice that rolls 1 and 5, and those are not equal. Rolls 1 and 6, those are not equal. Then 2 and 5, those are not. 4 and 2, those are not equal. 1 and 6, those are not. And finally 5 and 5, and those are equal, and it prints out doubles. Here it got it right away. 2 and 2, and those are doubles. Here it did 2 and 1, and then 6 and 6, and those are doubles, so it stops. The way this looks is as follows. This is just a simple function that's called roll until doubles. That function is called from the onClick here. We do roll 1 and then roll 2. We say roll 1 equals random int, roll 2 equals random int. And then while those rolls are not equal, we keep rolling. While loops and if statements look very similar. A while loop can execute its code an arbitrary number of times. It could be a whole bunch of times, it could be no times. An if statement will only execute its code once, or not at all. It won't keep executing that code. It only does it once, if it does it at all. So there is some redundancy in our code that we've just created. The roll 1 and roll 2 are assigned twice. So if we look at that code again, we have var roll 1, var roll 2. Those are assigned an initial integer between 1 and 6, and then another initial integer between 1 and 6. Another way of doing this is initializing a Boolean flag to determine when the loop should continue. So initially we say roll doubles is not true, so roll doubles equals false. So while we have not rolled doubles, we keep rolling them. And initially this is going to be false, so it's going to go in there no matter what one time. And it's going to do the roll 1 and the roll 2, and then it's going to continue depending on whether or not it has roll doubles. Now, loop tests are what we know as the thing in between the parentheses for the while loop. It defines the conditions under which the loop continues. So for example, sometimes this is backwards in the way we think about loops. So let's say we want to read input until we get a positive number. So we want to basically keep reading it until we have positive. So while it is not positive, we continue reading. So we say while input less than equal to 0, continue. Or, for example, we keep rolling the dice until we get doubles. So we say while roll 1 not equal to roll 2. Or we could say keep rolling the dice until you get double 4s. And it's important to remember here De Morgan's law. So saying well roll 1 not equal to 4 or roll 2 not equal to 4 is the same as saying not roll 1 equal 4 and roll 2 equal 4, where we would say not on that entire test. That's equivalent to saying not roll 1 equal 4 or not roll 2 equal 4. In other words, roll 1 not equal to 4 or roll 2 not equal to 4. Another thing that's important to understand is counter-driven loops. So a while loop is controlled by a condition. That means we can essentially fix the amount of times that we want it to repeat something. So we can say rep count in this case equals 0, while rep count is less than the desired number of repetitions. Then carry out some statements for those desired tasks. And then increment, this is what's called incrementing the rep count. So rep count equals rep count plus 1. So we set that to 0. We do our thing. We say rep count, which is going to be 0, equals 0 plus 1, so it's 1. We do our thing again. It comes through and it's going to be 1 plus 1, so it's going to be 2. Then it's going to be 2 plus 1, so it's going to be 3, and so on and so forth. Here's just some examples of counter-controlled loops. Here we're initializing the rep counter as long as we are less than 10 repetitions. We do this. Here we're initializing the rep counter as long as we are less than 100 repetitions, and then simulating the dice rolls for all of those times. The following example shows counter-driven dice, and it's going to roll this whatever we pass in to as the total number of rolls. So for example, our value that we're passing in equals the document.getElementById.value, which is set to 1000 here. So it's going to roll 1000 times in that particular case. So this is our value, 1000. We click to roll, and it says that it obtained 178 doubles from rolling it 1000 times. So this is an example of having an if statement inside of a while loop. So we say while rep count less than total rolls, roll 1 equals random 1 through 6, roll 2 equals random 1 through 6. If they are equal, we increment the double counter by double count equals double count plus 1. And then we also increment the rep count because we want to keep doing that until we've had that total number of rolls. It's possible to get what's called infinite loops. That means, and these are usually a bad thing, that means that the browser repeatedly executes statements inside of the while loop as long as that loop test succeeds. If you forget, for example, to increment the rep count in this case down below, you will get a infinite loop because rep count is 0. It's less than 10, it does its thing, and then it's less than 10 again and again and again. You have to make sure when you're coding up your loops that some part of the loop test changes inside of that loop. You have to make sure that that rep count is changing. Many times this can result in JavaScript programming in a frozen browser. Sometimes you might be able to click stop to stop that execution. Other times you may need to simply close out of the browser completely. You can use a variable to control the number of loop repetitions. That can also be updated in a number of ways. It does not have to be always going up. It can be going down. And this next example shows that. So first of all, we parse the float by the number of times we want to count down from. This is counting down from 10. So we say count equals parse float document.getElementById.value. Document getElementById in our HTML at first equals nothing. And then we add something each time to it. So the inner HTML equals the inner HTML that we currently have, plus count, plus br, and then count equals count minus 1. So if we want to count down from 15, we can enter the number 15. We begin our countdown, and it subtracts 1 from the count each time. Again, that's just a function with a local variable called count. Getting the value from that text box and doing a parse float on it, and then setting that each time to inner HTML equals whatever that is plus count, and then subtracting 1 from the count. And eventually at the end of the very end of the while loop, we just print blast off. There's other interesting examples of this in mathematics. This is a hailstone sequence. We start with any positive number, so it could be a random. If it's odd, we multiply the number by 3 and add 1. Otherwise, we divide it by 2. And we can repeat this as many times as desired, resulting in what's known as a mathematical sequence called hailstone. The conjecture is that you will always end up with 421 in the loop somewhere. So you could in theory write a program that proves this, or not proves it, but at least demonstrates it. It's still yet to be proven for all starting numbers. Mathematical proof does not exist. So in other words, what you could do is you could write a program that simulates this for, in this case they've showed and demonstrated that it's verifiable for up to this many numbers. And that concludes our chapter on conditional repetition. And so hopefully you've gotten something out of that. While loops and what you will come to know in Java as for loops are a very important part of computer science. So something that you'll use repeatedly throughout your degrees here at UWGB. Thanks for listening, and good luck on your midterms tonight.